In 2008, Nokia generated 50 billion euros in revenue. They were the single most dominant force in mobile. Then, in the space of 4 years, they lost everything. A catastrophic CEO destroyed their market share, handed the keys to Microsoft, and left Nokia with less than 3% of the smartphone market. By 2013, most people assumed Nokia was simply done. But here's what nobody saw coming. It's June 2026, and Nokia's market cap has just crossed $82 billion, a 240% rally from its 2024 low of $24 billion. Their Q1 operating profit beat Wall Street estimates by 11%, and Jensen Huang, the most powerful man in semiconductors, just publicly named Nokia as Nvidia's primary telco platform at GTC 2026. Nvidia didn't just say it, they backed it with $1 billion, 166 million shares, a formal equity stake. So how does a company that lost the smartphone war become the infrastructure play of the AI era? The answer involves something almost nobody is talking about. Nokia and Nvidia are quietly converting ordinary cell towers into distributed edge AI data centers, not building new ones. The tower's already outside your window. T-Mobile just completed the first live commercial trial in the US, running Nvidia's Blackwell servers through Nokia's software, turning a standard cell site into a low-latency AI processing node. The total addressable market for this technology is projected to exceed $200 billion by 2030. Nokia is betting the entire company on getting there first, and the evidence suggests they might actually be right. When a company needs to change direction, it usually starts with a press release. Nokia did something more surgical. On April 1st, 2025, Justin Hotard walked into Nokia's Helsinki headquarters as the new president and CEO. His previous job was running Intel's data center and AI group, one of the most demanding hardware divisions in Silicon Valley. He had spent his career thinking about GPU architectures, hyperscaler demand, and semiconductor supply chains, not cell towers, not carrier contracts, not the slow, negotiated cycles of traditional telecom. That was the point. His predecessor, Pekka Lundmark, had done respectable work re-establishing Nokia's 5G baseline after years of execution failures. But the board had a different problem now. The AI infrastructure supercycle was accelerating, and Nokia's leadership team was still built for the last war. Hotard was brought in specifically because he understood the customers Nokia needed next: Amazon, Microsoft, Google, the hyperscalers pouring hundreds of billions into AI compute. The cleanse began immediately. Tommi Wiito, Nokia's long-serving president of mobile networks, departed on December 31st, 2025. His exit wasn't a routine retirement. According to internal sourcing, Wiito disagreed with Hotard's aggressive push toward software-defined interfaces and network virtualization. That disagreement ended his 30-year tenure. His replacement, Emma Falk, recruited from Siemens with a background in computational physics and industrial automation, wasn't a telecom veteran. She was an engineer who understood how physical infrastructure gets converted into intelligent, software-controlled systems. That distinction matters enormously for what Nokia is building. David Hurd, the former CEO of Infinera, was installed as president of network infrastructure. He came in as Nokia was absorbing Infinera's optical transport business. A $2.3 billion acquisition closed February 28, 2025, making Nokia the second largest optical networking vendor globally. None of this was cosmetic. On January 1st, 2026, Nokia implemented a dual-segment operating model. Network infrastructure became the primary growth engine, combining optical networks, IP networks, and fixed networks into a single high-margin unit. Mobile networks and cloud and network services were consolidated into a single mobile infrastructure segment, deliberately uniting cellular standards work with Nokia's IP licensing division, which runs at gross margins near 100%. That licensing arm, Nokia Technologies, generated a contracted 1.40 billion euros annual run rate in royalties alone. Attaching it structurally to the mobile division wasn't an accounting preference, it was a cash flow strategy, using patent royalties to subsidize the capital-intensive build-out of AI-native infrastructure. The cost of executing this restructure was real. Full year 2025 net sales came in at 19.89 billion euros. Comparable operating profit fell to 2.02 billion euros, a 22% drop from 2024. Nokia absorbed 250 million euros in restructuring charges to achieve the new segment structure. That figure represents thousands of headcount reductions, division eliminations, and organizational layers stripped out. Companies that are rebranding take out ads. Companies that are actually restructuring take the charge and accept the short-term pain. Nokia took the charge. Jensen Huang doesn't make $1 billion bets casually. On October 28, 2025, Nvidia announced it was purchasing 166.4 million newly issued Nokia shares at $6.01 per share. A $1 billion equity stake, 2.9% ownership. Not a licensing deal, not a co-marketing agreement. An actual equity position in a Finnish telecommunications company that most of Silicon Valley had written off years earlier. So, why Nokia? The answer isn't about Nokia's brand or its history, it's about a specific piece of software called AnyRAN, and what it can do when it runs on Nvidia's Blackwell server architecture. To understand why this matters, you need to understand what a cell tower actually does today. The industry standard for decades has been a system called remote radio heads. A cell tower transmits signals. Specialized, single-purpose hardware handles the baseband processing, converting radio signals into digital data. That hardware does one thing. It cannot be repurposed. It sits on a tower doing its job and nothing else, even at 3 a.m. when cellular traffic drops to almost nothing and 90% of its compute capacity sits completely idle. Nokia's AIRAN model is built on a fundamentally different premise. Instead of purpose-built radio hardware, Nokia installs standardized GPU-based edge servers at cell sites. Nokia's AnyRAN software runs the 5G baseband processing functions, the same functions the old dedicated hardware performed, but entirely in software, directly on those GPU servers. During peak cellular traffic hours, the GPUs allocate most of their compute power to network processing. During off-peak hours, that same hardware dynamically shifts its idle capacity to run third-party AI workloads, enterprise inference jobs, video analytics, autonomous vehicle coordination, industrial automation tasks. The cell tower stops being a single-use radio asset. It becomes a distributed edge data center that generates two revenue streams from the same piece of hardware. This isn't theoretical. T-Mobile US recently completed the first live commercial trial of this architecture in the United States. Nvidia's Blackwell Server Edition infrastructure, integrated with Nokia's AnyRAN software, was deployed at a standard commercial cell site. The trial successfully converted that tower into a low-latency edge AI processing node, running both active 5G traffic and AI inference workloads simultaneously on shared GPU hardware. One cell tower, two revenue streams, zero additional hardware footprint. Now multiply that by the roughly 400,000 cell sites currently operating across the United States alone. That is the scale of what Nokia and Nvidia are attempting to build. And that is precisely why Huang called Nokia his primary telco platform at GTC 2026, not because Nokia was the most famous name in the room, but because Nokia was the only company with software already capable of running on Blackwell at commercial scale. Ericsson can't say the same. On January 27, 2026, Ericsson publicly declined to sign an exclusive equity partnership with Nvidia, choosing instead to maintain what they called architecture neutrality, keeping their options open across multiple silicon vendors. On the surface, that sounds prudent. But in a market where Nvidia's Blackwell architecture is rapidly becoming the dominant edge compute standard, neutrality is another word for delay. Huawei faces a different problem entirely. Their hardware architectures are deeply integrated with proprietary silicon developed specifically for traditional 5G deployments. Rebuilding those stacks for GPU-accelerated, software-defined infrastructure would require dismantling engineering decisions made across the last decade. Western sanctions complicate their access to the advanced chips required to do it. Nokia, by contrast, spent 2025 systematically stripping out the legacy hardware dependencies that would have made this pivot impossible. The January 2026 segment consolidation wasn't just administrative. It removed the organizational barriers between Nokia's radio software teams and its IP networking division, allowing engineers across both units to work toward a unified, software-defined architecture running on shared commercial GPU hardware. Ericsson chose neutrality. Huawei is structurally constrained. Nokia signed the deal, took the equity, and got Blackwell certified first. In infrastructure markets, first-mover advantages compound. Operators who deploy Nokia's AI RAN architecture now are building network management systems, automation tooling, and operational workflows around Nokia's software stack. Switching costs accumulate quickly, and with Indosat Ooredoo Hutchison signing a nationwide AI RAN deployment agreement for Indonesia on June 12, 2026, the first country-scale commercial rollout of this architecture, the window for competitors to catch up is narrowing by the quarter. Let's talk about what Nokia actually needs to prove. The restructuring is done. The Nvidia deal is closed. The T-Mobile trial succeeded. But none of that generates the operating profit targets Nokia has now committed to publicly. And in this industry, public commitments have a way of becoming obituaries when they're missed. Nokia's management has set a comparable operating profit target of 2.7 billion euros to 3.2 billion euros by 2028. For context, full-year 2025 comparable operating profit came in at 2.02 billion euros. That means Nokia is targeting a 33% to 58% expansion in operating profit over 3 years, while simultaneously absorbing the capital costs of building out AI RAN infrastructure at commercial scale. The math only works if the product mix shifts dramatically. Legacy 5G radio hardware, the antenna units, the baseband cards, the purpose-built physical components Nokia spent the last decade manufacturing, carries relatively thin margins. It's a competitive, commoditized hardware market with pricing pressure from every direction. Nokia's IP licensing division, by contrast, runs at gross margins near 100%. Its technology standards segment generated 385 million euros in net sales in Q1 2026 alone, up 10% year-over-year on the back of new patent agreements across consumer electronics, multimedia, and automotive sectors. The 2028 profit corridor is essentially a bet that AI RAN software licensing, optical networking services, and IP royalties will grow fast enough to structurally replace the margin contribution of the hardware categories Nokia is deliberately walking away from. Every executive departure in 2025, every segment consolidation, every divestiture, the submarine cable unit sold to the French state for 350 million euros, the Chinese joint ventures unwound, all of it was preparation for a company whose profits come primarily from software and intellectual property, not from shipping physical boxes. Now consider the market those software profits are chasing. Omdia projects the cumulative total addressable market for AI RAN technology will exceed $200 billion by 2030. The broader global AI infrastructure market, per Grand View Research, is expanding at a 30.4% compound annual growth rate toward $223 billion by the same year. Nokia is not positioning itself as a participant in that market. It is positioning itself as the infrastructure layer underneath it, the software stack that every AI workload running at the network edge has to pass through. That is the shift from telco vendor to AI infrastructure utility, and it's a fundamentally different valuation story. But there is one more piece. On June 11, 2026, Nokia introduced its agentic AI framework into its network services platform. This isn't a marketing feature. An agentic AI system doesn't just monitor a network, it reasons about it. Nokia's framework deploys autonomous AI agents that analyze real-time IP telemetry, protocol behavior, configuration state, and physical network topology simultaneously. When something breaks, the system doesn't generate an alarm. It traces the root cause, builds an explainable workflow, and resolves the issue, without a human engineer initiating the process. The framework communicates via the Model Context Protocol, meaning it can coordinate with external AI agents across multi-vendor networks. Nokia isn't just running AI workloads on cell towers, it's deploying AI to manage the cell towers running the AI workloads. That recursive loop, infrastructure that maintains itself, is what separates a hardware company from a utility. Here's the core lesson this entire story teaches. Nokia nearly died because it refused to accept that the smartphone era had made its core product obsolete. It held on to Symbian while Apple built an ecosystem. It partnered with Microsoft while Android consumed the market. By the time it acknowledged the reality in front of it, the opportunity was gone. What's different now is the timing. Nokia identified the AI infrastructure supercycle early enough to act, before the market calcified around a winner. It brought in a CEO from Intel's data center division before the AI-RAN category even had a formal name. It signed Nvidia before Ericsson understood the urgency. It built any RAN software before operators knew they needed it. The most valuable real estate in the world by 2030 will not be a hyperscaler data center in Virginia or Texas. It will be the 400,000 cell towers already embedded in cities, suburbs, and industrial zones across America, and the hundreds of thousands more distributed across Europe, Asia, and Latin America. Nokia is not building that infrastructure. It already exists. Nokia is converting it, tower by tower, into intelligent compute nodes that process AI workloads, manage themselves, and generate software revenues that legacy hardware never could. That is not a telecom story. It is an infrastructure story, and it is only just beginning. If the industrial AI transition is the biggest capital reallocation of the decade, you need to understand every company sitting at its foundation. Subscribe, and we'll map the entire chain.